Now we'll derive the formula for parallel resistors, having already done series resistors. So on the left, we have a circuit that has elements in parallel. And what we'd like to do is simplify it to something on the right, that is a simple battery with one single equivalent resistor. What is the formula for the equivalent resistor? So we had two laws before, Kirchhoff's current law, Kirchhoff's voltage law. In the current law, the sum of the currents into a node had to sum up to be 0. In the voltage law, the sum of the volts around a closed loop had to sum up to be 0. So, in the case of the current law, we'll start off with that first. I'm going to choose a node on this first diagram, and that'll be node A. So I'll have I naught coming out of the battery, I1 going through R1, and I2 going through R2. So by Kirchhoff's current law, what I'll have is current going into the battery, current going into node A from the battery, and then the currents that are going out, so I'll give it a minus sign to be going out, are I1 and I2. Those have to be summing to 0, or I naught equals I1 plus I2. Now, I know what I'm trying to get to is voltage of the battery equals I times R equivalent. And that I, in this case, I do know what it is. It's the I naught out of the battery. So I also know something about the voltage drop across each resistor from the toolbox. So remember down here in the toolbox area, I can always use V equals IR. And so I'm going to use V equals IR in this location across that R1 and across the R2. So in that case, what I'll get is V1, or delta V1, the voltage across that is going to be I1 R1, and delta V2 equals I2 R2. And now the key thing about parallel circuits, and that is, since I have on the top, and I'll outline it here in blue, on top I'll have all the same voltage along that line, and I'll have all the same voltage along this line. So we'll call this volts equals 0, and this volts equal volts of the battery. So what that means is that every single element, R1 and R2, have the same voltage. So that's the important thing. Delta V is the same for all parallel components. So we'll be able to take advantage of that, and we'll plug it into this main equation. So what we're going to do is take this equation, I'll call it equation number 1, and number 1 with V equal IR applied. Or said another way, V divided by R equals I. So I'm going to go ahead and use that with these three other equations I have. So here's equation number 2, number 3, number 4. So I'm going to take 2, 3, and 4 and rearrange them as in this V equals IR fashion and plug them into number 1. So doing that, what I'm going to have is V of the battery divided by R equivalent equals V1 over R1 plus V2 over R2. And remembering that these guys are all the same value because of that fact, then basically they'll divide out. And that will leave us with 1 over R equivalent is equal to 1 over R1 plus 1 over R2. And if I had other resistors in there, I could just keep adding them on in that inverse fashion. And that gives us a formula for parallel resistors.